Hello everyone, welcome to my channel Beyond Unit Conversion at AutoCalcs. In this video, I'm going to share an example how we can get rid of magic numbers in a lot of equations and bring us back to the essence of physics. In this example, it's about piping sizing based on fluid capacity. You can see traditional people use this kind of equation, which is specific to specific unit. Like this is for the based on the flow capacity area of the pipe equals to the GPM, which is actually the flow capacity, and divided by V velocity. Right? But as you can see, the traditional people use this kind of equation combined with specific units, and because of the specific units, it comes with this magic number. Like for here is 0.3208. But in essence, what we are doing is actually the physics equations like this. A for the area of the pipe equals to Q divided by V, and the diameter equals square root of 4 times A divided by pi. Or if we plug that A into this, it becomes this. Right? Because when I did some hydraulic calculation recently in order to size a pipe, I was using one of the engineering guide from Eaton. Sorry, let's burn that. So here is a document, Vickers wind pump and motor design guide. At the end of this document, it provided this chart for people to size the piping, right? Flow capacity of piping, and it gives it here. It says this chart is based on this formula. That's what I used over there to here. Let's bring this up. So I want to talk a little bit about the traditional way that I found from Eaton's website first, because I think people used to do this, and it was whoever developed this must be a very smart guy, and I believe that nowadays people still use it. What this does is actually between this area, GPM is for flow capacity and velocity. Between these three quantities, if we know any of two, then we can calculate the third, right? But actually for area, for the pipe, what we are actually interested in is the pipe diameter rather than the area, right? But anyway, this basically is what it does. Like if you draw a line, if you know any of the two quantities, you mark the marker point on the spectrum. This is for the velocity, and this is for the area or diameter, and this is for the flow capacity, right? We mark the 2 points, and then the third one we draw a line, and then the third point is crossing the third line. So that's how we find the third quantity. Okay. After a little bit study into this, I realized, I can do this with my unit conversion unified calculations. So I created this calculation. So as you can see here, in order to size the diameter of your pipe or tube or hose, what I needed is a D, right? D, in order to get D for a pipe, we need to get the area, right? So we know that in hydraulic calculations, flow in a pipe equals the flow capacity divided by speed or velocity of the flow. So just as an example, let's just make it comparable with what we can get from here. Over here, V is about, let's bring this up. V is about 9.6, let's say, right? And GPM for flow gallons per minute is about on this line. That is cubic inches per minute. This is GPM. So that we can see like 11, 12, 13. So it's about 13 something, right? So let's come to here. And let's just use the same units, GPM. And feet per second. So we know that it was 9 point something, right? Let's say it's 9.6. Let's change that to be 9.6, right? And GPM is about 13 point something. Let's say it's 13.5. Let's just make it. Okay. So with this Q and V, then it automatically just calculate the diameter, the inside diameter to be 19 point. Let's change that to be inches. So it's about 3/4. So as you can, let's just compare. Okay, you can see like the crossing point is at 3/4 for the actual inside diameter, right? So it's pretty close, right? But the benefit of this unit conversion unified calculation is not like this equation, which is only applicable for when you have this, when you use the specific units and with the specific magic number 0.328. It's hard to memorize anyway, unless you're working in this kind of industry very frequently. But back to this unit conversion, unified calculations, you can see like these are just the very basic equations, just like this. So simple to understand, right? And just use it as it is. There is no conversion on the user side, right? If we want to change that to be metric liters per minute, we just switch that, change that unit directly from the drop-down list. You switch it. Previously, this was, so you can, if you turn this back, we can still say that's still the same flow capacity, 13.5. The same thing for this flow speed and velocity. If we want to change that to be meters per second, that's 2.9. We change back feet per second, 9.6. The same thing for the result. When it is inches, it's about 3/4. If we want to show that in metrics, it's 19.25, something like that. Right? So this gives us the complete flexibility to use whatever units you like, handy. Either it's on the input side or it's on the calculated result. Only if you change the input will change. Like if you change it to be 30 gallons per hour, so because it's bigger, right? So you can imagine that it's going to be bigger, right? So as simple as that, you can still change that to be metric. Okay, once you get familiar with this, then you don't need these images too. So now the screen is clean. You can just use it as just like an app with units conversion automated. So that's an example showing you how to get rid of the magic number when we do calculations. Hope you like it. If you do, please click the button to like it, and hopefully you can help to share this video with your friends. That will help me to do more calculations, develop more calculations to be more helpful for more people. Okay, thanks very much for your time anyway. Bye for now.